So we're here to talk about what it means to do Agile for hardware, or at least a model that we're developing for how to look at this and how to be Agile, not only in the actual project execution, but even the way you think about how to manage the project. You know, so this idea of adaptability, the things that drive Agile is not new, and here it goes back to the old riddle of the Sphinx, and in fact, Mark has put together a nice set of nice video, even thinking about how the pyramid development was Agile and how they adapted along the way. So we really want to think about how do we keep that level of adaptability in the development of new products. And just to give this a little bit of context, you know, where did, you know, Mark and I come from? Where did we develop this model that we're going to talk about today? And, you know, we've been doing development of physical products, mostly in the B2B world, with embedded software, fairly complicated. And, you know, we've seen lots of advantages to being Agile, although we've seen lots of challenges using the standard Agile frameworks that are available for software development, because there are a lot of things that are quite a bit different in physical product development. Just to, again, go back a little bit of examples of products that Mark and I have been involved in developing over the last years, and you can see these complicated, I can get this in my laser pointer here, you know, valves, you know, very, very tight tolerances, tight requirements, joysticks, there's software to convert the motion of the joystick, and a lot of work on the ergonomics and a lot of touch and feel, a lot of feedback. Similarly, on these displays that have been developed, again, lots of subjective feeling feedback that we need on, is it bright enough? You know, lots of unique characteristics. So these things are, you know, all have many disciplines in here, all have mechanical engineering. Of course, we have to put it into production. We've got people from market launch because we need to sell it, and we would have an electrical engineering, and then we had optical engineering in for the displays. So many more different kinds of disciplines of people that we need than you might typically need in a software-only development project. The model that we're going to talk about today is something that we're calling a D-cubed model for doing this. And I just want to set a little bit of a statement of, you know, where is this applicable? And where we've used this and where we really advocate using this is more on these platform projects, not an incremental addition. The things that you saw were all new products to us. Don't have much experience in real breakthrough products. I believe that this model will hold in that, but it's unproven, and the relative time in the different phases that we're going to talk about might be quite different than in a typical platform project. But we are also talking about things that go through three very distinct phases in their development, and the derivative products may not go through that. They may not have the level of uncertainty at the beginning that we see in a platform development. So talk a little bit about, and there were some questions about why, you know, what makes it much more difficult to do Agile development in hardware, you know, and we look at a lot of contrast here where in software development, and in particular things that are user interface and user experience, good enough can be very subjective. You look at the products that we talked about, we're developing a pump and it has to generate a certain amount of flow. So it's very dominated by objective criteria. The software development process can run through sort of exactly the same process, loop after loop, feature after feature, where you go through this to specify design, code, test loop for each feature, whereas hardware development goes through a much more of a maturity, the old classical sort of alpha, beta prototypes, and then going into production. And again, we've got these challenges with the hardware. You go back to that picture of a pump. What would it mean to, I've put that pump, and the customers that we have at Danfoss are people like John Deere and Caterpillar and Bobcat. You can't go out to them and say, oops, we need to replace the pump that's in your piece of equipment in the field. And of course, we have, production is critical here. It can be at least as critical. The other thing is, we talked about it, the breadth of sort of the types of people, and we do hardware development. We talked about there, we have some of those things. We have optical engineering, mechanical engineering, electrical engineering, advanced manufacturing, procurement, people in product launch and application engineering. And so this idea, we talk about trying to have a small 7-person team that can develop a significant portion of software and be a Scrum team. And that those people can have some overlap, and they can get this sort of, you can see it so well on the monitor, the sort of T-shaped profile we talk about, so people can help each other out a whole lot. That gets very difficult in hardware, where the person who's an expert in procurement is not likely to be able to contribute a whole lot to the development of an electronic schematic, for example. So we want to take another Menti poll here and get your feedback on what kinds of challenges you have seen when you've tried to implement agile practices for hardware. Let me come here and make sure we go to the next thing. And so we've got 5 different things, and just tell us for each of those on a scale of, I think it's 1 to 4, Mark, what level of challenges you've seen here.
That's correct, yes. And there are little explanations on them when you go to the Menti as well. And there's also the option of skipping the different questions if they're not applying to you at all.
Yep. As you're thinking, it's one of the things that we've seen as a challenge. There was a question about using Scrum as a challenge that we've definitely seen in our environment, of the role of the product owner, that it's an almost impossible job in physical products, where people, in a software only, you can have someone who understands the software development, and the work for developing software is very dependent on the feature and the priority, and the work in hardware development gets very, very separated from the work of specifying the product as we go through these things. So we see, lots of challenges with people with demonstrable outcomes after a short sprint, definitely a challenge. Challenges implementing a model that fits manufacturing. Mark, anything you want to add about your experiences with some of these challenges?
Yeah, I mean, we have been through them over the many years. I mean, I went through the first so-called agile transformation 15 years ago, and I'm one of those that have tried, see how well it works in software, and came out as as a big advocate, as a zealot for agile almost, and went from the software world straight into the mechanical world, and found out that trying to implement Scrum there absolutely did not work. There were many challenges with it, at least. So yes, I can definitely find meaning in many of the questions here, that's for sure. But there's also solutions to them. There is hope.
Yep. Yeah.
That's what experience is, right? That's just
Yeah. It's interesting looking at these plots that we don't see, isn't a whole lot of difference in the aggregate answer, but some very different results in terms of the distribution of where people are seeing challenges with these elements. All right. Again, feel free to add that, and also really encourage you to add comments into the chat of your experience in the challenges with these things. All right, so let's proceed on. And so what I want to talk about here is, again, another little bit of setting the stage here, that you know, the model that we're going to talk about here is essentially that there's a product development project that we've decided to run. We're not going to talk about things you could do out in the fuzzy front end. Working here, and something that there is a broadly understood market for the solution. So we're not doing radical market exploration here. And then, of course, that the problem we're trying to solve with this product and the solution that we're imagining fit in with the strategy. And of course, assuming that we have resources here, I'm not going to talk about, all the challenges that we all really face in the real world of keeping the teams together. We're going to start with the assumption that you have a team that it can stay together and work on the project. And so what we want to talk about here is an idea that these hardware development projects, once they're into execution, go through three very distinct phases, and that we want to manage them rather differently. We start with the discovery phase. We sort of have that idea on a napkin, and we need to take it to a concept, mature the requirements, work on launch goal. And this is a phase with very high uncertainty and a place where we need to learn a lot, so that when we can get into the engineering world, into the deep engineering tasks, that we really are getting into something that is, it's certainly not no risk, but relatively low risk development. There's really another assumption here that we're not taking in new technology development. And then once we get that stabilization of our concept and our launch strategy, then we get into a detailing phase, where this is the place where the engineers are working on those detailed drawings, starting to build the model of the product that starts looking like, has that form, fit, and function, and starts getting really close to even the manufacturing process. And it's also the place where we are building up and designing our manufacturing and assembly process. And we're really getting also figuring out exactly how we're going to launch. At some point in all of this, we get a working prototype that does get to that, look and feel of the production product. So it has the form, fit, and function. Maybe not all of, at that point, not everything comes from manufacturing tooling. And then we go into that phase is how do we take that product that has that form, fit, and function and drive it that last step to make it manufacturable, get us ready to launch, do the preparation. And this is a phase where there is much less certainty. And generally, the organizations have a long checklist of things you have to achieve for that. At least, we come from in Danfoss, we have very automotive standards when you go through what's called a production part approval process, sort of comes out of automotive, and a long list of things we need for selling material for the customers, and things that are probably a little more consumer is also start filling the pipeline at your sales outlets. So I want to walk through in this presentation is what do each of those phases of a project look like, and how do you think about it so that you can run this project effectively. And we're going to start in the discovery phase. And as I said, this is a place where we start out with an idea, really kind of the proverbial sketch on a napkin, and we want to turn that into some reality of a concept. And oops, I forgot to take the help out. And the problems that we often see in this phase is this thing can run on forever. We did a project, we looked at those displays that we had. We knew fundamentally what we wanted to do, after about 2-3 months in this phase, and it dragged out for a year because there was always one more question to ask, one more person we could talk to, one more opinion we could get. So we need some way to drive the decision-making process. The other failure we've seen, and it's happened a few times, is you try to start planning too early, and the project manager, they gets excited in the team and say, let's plan everything all the way out till we're done with the project. And there's so much we don't know that we can't that doesn't make sense. So we want to, at this point, focus our planning on what do we need to do to develop these product production and launch concepts, and then work out this much more the next level and more detailed plan later for how to go through the detailing and really get to the full realization of the product. And again, we talk about this phase is, all of these decisions, what precisely does it need to do? How and where do we build it? How do we go to market? And, those are the big decisions, but those are the things that we need to answer and resolve fairly early. And the way that we suggest doing this, and this is a model that has been most advocated by Catherine Rodica and her rapid learning cycle model, is that you build this phase and you build your planning in this phase based on the decisions that you need to make. Figure out what decisions are really key, and then what the most important information is to learn in order to make those decisions. It's a very effective process, and it helps you avoid that analysis paralysis, that there's always one more thing you could learn. You get to the point where you've agreed to make various decisions in the process, and then if you're not comfortable that, you talk about not what you could learn, but the risk that you're taking by making the decision with the information that you have already. And within each of these learn and decide phases, we also want to make sure that we have a diverge and converge mentality. We start at the beginning of these loops and work to explore what are the possibilities before we converge on an answer. It's really easy in these stages to say, here's what we think the answer is, and then convince ourselves that it's right. We really want to take some time and learn and converge, to learn and diverge. And in this process that can be a little more complicated than this, than what we see and really advocated in that rapid learning cycle model is, in fact, you might have several sprints of learning before you make a decision. So you have, you might say, okay, we're going to run on a high cadence, we're going to learn, we're going to decide what we're going to focus on and learn over the next 2 weeks, but maybe those decision points that come every 6 weeks or 8 weeks, but we still keep that learning in mind, and we go back at the end of each of those sprints and say, did we learn what we wanted to learn? Did we learn that we need to learn something different and close a different knowledge gap in here? And so this, by going through this very disciplined learn and decide looping process, we can drive this to conclusion in a relatively short period of time. We also want to make sure in this that we're not trying to make decisions too early. We always talk about this concept of making decisions at the last responsible moment. So in this, we'll think early about what we need to decide and what can be pushed into later stages of the project and into the development.
Brian, could you comment real quickly on how this process helps with risk mitigation, risk management?
So, so the question was around risk mitigation. Absolutely, because there's a lot of things we need to decide, and it describes, and those decisions always have risk to them. And the other way it helps in the risk mitigation is if we think that something might happen, and we can say, well, what do we need to learn? How do we figure out how to, we really think about what are the chances of that happening. I don't know, Mark, if you want to add anything in this learning on the risk mitigation.
Yeah, definitely. Risk mitigation is a big topic in general, and it's especially a big topic in Agile that we probably cannot do full justice to today. But I think what we're really wanting to avoid is that we make the wrong decisions, first of all, because they can become very, very expensive down the line. And the other one is that we want to avoid investing too much money that'll be wasted, right? And really, this is all about ensuring that, because if we are being very conscious about which decisions we take early and which decisions it's okay to take later, then we're actually reducing the risks all the way along, because we take the decisions when we have the best possible knowledge to take those decisions. And that means that we're making better decisions. Making all of the decisions early is not necessarily good, because the earlier we make the decisions, the higher our uncertainty is. So this is actually helping us a lot in mitigating risks.
So it is explicitly looking at what you don't know and looking to try to close those knowledge gaps in order to make key decisions early, and not so that you end up with a better, lower risk project overall. Is that right?
Yep. Thank you, Steve. Yep.
And the other point also, I think, is also very important here. Realizing that we can also change our minds on the stuff that we are uncertain about. So we can take a decision and go down that path and change our minds later if we know we're uncertain. That can also help us in asking for the right amount of investments. So we have a tendency to ask for the whole investment up front, but if we know we're uncertain, we can ask for smaller investments, go and do smaller investments, test out our ideas, and if they fail, it has not cost us a lot to go down the wrong route. So fail fast, fail early, or learn fast. Mindset.
Right. I mean, this is Pete. I've come from risk management background, so I could kind of see going agile is really doing the assessment on every loop, so to speak, and then making a decision. So you're not starting the business, let's say our product, and then very end, then you say, did we fail or not? You make adjustments. So that's part of mitigation going in agile, is kind of driving that. Not only you have like a mitigation, you also almost like putting a control and assessing it every often. And that's one of the biggest aspect of risk management.
I think the other thing I see in terms of risk management is when we make these decisions, we sometimes, as Mark said, we don't make an absolute decision. We've narrowed our choices dramatically, and say we may still carry things that in sort of in a small band, and say, yeah, we're going to start in the middle, but we know we're going to leave ourselves flexibility to slide to one end of that band or the other. Right. Well, let's move on here. Oops. And go to as we get into the detail phase here. It seems like I've lost a slide here. No, as we get into the detail phase, one of the things we really want to think about, and if we follow a very kind of waterfall approach, we often end up with things where we are testing things at the very end and leave ourselves very high risky tasks. And one of the things we want to build into our system is some sort of iterative approach, so that we know that there's 10 meters of falling that we're going to need to do in this project, and we want to set ourselves up so that we can fall 1 meter 10 times, which is pretty painless, as opposed to falling off that 10-meter rooftop, which is pretty dangerous. And the way we do that is we think about, and this does kind of get back to more classic alpha, beta kind of things, is what are the iterations of the whole product that we want to go through in order to advance its maturity. Don't know how many they're going to be, but we want to think about it. And often that the first iteration is only demonstrating a few key critical elements of it, not even the whole product. But it supports our continued mindset of learning. But these learning loops, these product iterations, take a lot longer than any sensible sprint. What I've seen in development of electronics is to get the first full one, can take 6 to 8 months, but we need to work at it in a set of time boxes so that we don't end up in a situation where people are falling into the student syndrome, said, oh, I've got 6 months to get this done. We use that time box mentality to do it. We don't worry so much about presenting to some big management group at every sprint, but we do always want to make sure that within each of our time boxes that we have a review process with subject matter experts. So we're always checking that not only are we making the progress we do, but we're making the progress that we want with great quality. What I've seen in this is, in general, often that first iteration, the first full iteration of the product is by far the longest. Subsequent iterations, which then become tweaks to the product, can go much faster. I don't have to develop, I don't have to detail out my concept. I've got to change a few dimensions here and there, change a few components on the board here and there. The other thing in this process, when here we're talking mostly about the hardware, but in most of the things we do, there is software in it as well. And the software can be developed in a little more Scrum-like fashion, but we still do have the thing, at least the products that we've been working on, that the definition of done for the software is much more fixed and concrete and inflexible. So we do need it to get going. And of course we need to, so we think about what we want to prove and demonstrate with each iteration of the product as it's maturing. We also always want to make sure that we have all of the software and the software features and the software maturity to go along to be able to do the testing that we want to in parallel.
And a big part of that is also challenging ourselves, challenging the development teams about what a prototype and what a release actually is. I mean, you can test a lot of hypotheses by cutting in cardboard or by making 3D prints of stuff, right? If you have a doubt if the envelope of something fits the environment or whatever it is, you can cut it out. I mean, you can do a lot with challenging the mindset of what you actually need to do. You do not necessarily have to release fully certified products in order to test what you want to do.
Yep. And once we get through, go ahead. There's a question?
No questions in the chat, at least.
Oh, okay. I thought I heard a question from someone. And once that design is stable, we've gone through however many iterations it takes. And, at that point, this is about the design being stable, not necessarily frozen. So we get to a point, we know it works. We have a really good sense at the end of the detailing phase of how we're going to produce the product. At that point, we should, with each of those iterations that we talked about, be getting the product into the hands of customers or something that represents the customers to get some feedback, to know where we need to make some tweaks. We didn't talk it. There should be a lot of customer involvement and customer interaction in the discover phase to make sure that we're solving the right problem, that we have a general concept to get there. As we get into the deploy phase, the uncertainty changes. In discover and detail, there's a lot, in discover there's a lot of uncertainty about what we should do. In the detail, there's about how we should do it and can it be done. When we get into the deploy phase, it's much more about how long is it going to take to do the stuff that we know how to do, have done before, and it gets driven by supplier lead times, getting those detailed capability studies, that final testing, checking off that checklist, getting all of those documents and all the collateral you need to be able to sell, making sure that all of those things in the process FMEA have been addressed as we go on. And so when we get into this phase, when we get down to checklist, it starts making a lot more sense to follow either more of a Kanban or even going back to things we can schedule, with a Gantt chart. There may not, there obviously there's dependencies of things coming together, but there may not be a lot of interdependency of, part A doesn't depend on part B anymore. We've got the suppliers, they're working to do it. And at this point, you're going to drive this in a much more waterfall-ish way. We may not need sprints because we may have a lot of things that are driven by long lead times to get things in from our suppliers. So
I think just a quick comment there as well, also out from the real world. I think this realization here is one of those that has really given the organizations I've been part of the biggest benefits. because we kept having the mindset of how do we wrap these things here? How do we wrap the deliveries from the suppliers? How do we wrap our production in this agile mindset here? How do we fit things into sprints? How do we put it on Kanban boards? And I mean, people from production, people from the suppliers, people from procurement have looked at me funny when we have been trying to do these transformations here, but actually setting ourselves free from these things and say, it's fair enough. Those methodologies, they are really, really good when we are driving high complexities. But when we are getting to these things here that the organization knows how to do, it is okay to combine the agile methodologies with the good traditional ones that work for that. That was really liberating, and it has helped a lot to not stick, yeah, I would almost say rigidly to the agile processes, but also be agile about the agile processes. This one here has been strong in my experience.
Okay. All right. So again, really to wrap up here is, what do we think about? What do we want to keep consistent? Is we want to use time box to maintain that velocity, avoid the student syndrome, keep the mindset of just-in-time planning, because even the best of circumstances, we our ability to see what's going to happen as we get 4, 6, 8 weeks out gets real fuzzy, even at that back end, because we're relying on our suppliers to deliver. And in every project, there's at least one supplier who doesn't deliver on time. And it's also important to always keep, and we haven't talked about this much, a high level plan. Make sure you know where the North Star of the project is, because it's really easy when you get into these things we're working in sprints to get very focused on what am I doing in the here and now and lose sight of that big picture. But what do we want to adapt is really in this discovery phase, drive the loops, drive the time box, drive the loops on these learning loops, and we get into detail, drive it with the whole product iterations, and we get into deployment. It can look much more waterfall-like. There might not be a whole lot of big loops that the time boxes need to support.
Well, I want to thank Brian and Mark for the presentation tonight. Hopefully everybody got something out of it, some nuggets they can take back to their work. I think having a mixed approach to project management when it comes to based on where you are in the hardware project, from the learning phase to the development phase to the deployment phase, makes a lot of sense in an agile product development world.